Welcome back to the second last part of the tutorial. Now we can start coding. Interesting, isn't it? There's so much we have to or we can plan and do before we just randomly start creating C++ classes and typing code, right? Anyway, back in Visual Studio, you will now see that the player controller class is already selected with its header and C++ file. Both are open. In your header file, testplayercontroller.h, you can see that some of the code has already been generated by Unreal Engine when it created your classes. This is called boilerplate code and it provides a handy starting point. Now, we need a few things before we start fleshing out our switching function. Firstly, we need a very essential function that is derived from our base class, the AirPlayer controller, called BeginPlay. So here is how we create it. Navigate to generated body, press enter a little bit, type in virtual void BeginPlay. Make sure there are brackets to indicate that it's function, and then type in override. Do not forget the semicolon. Right? This is how we do it. Wonderful. We have just created a declaration of our function in the header file. For convenience, Visual Studio offers a unique way of creating a definition of our declaration through quick actions and refactoring. We usually create our declarations in the header file and definitions in the C++ file. If you have a background in computer science, or if you have done some programming in C and C++, you will know that there's structured programming and there's object-oriented programming. Essentially what happens is all the stuff in the header file gets put right above here. So basically by saying hash include testplayercontroller.h, we are essentially saying to the compiler, copy and paste all of this and paste it here, and then we can start creating the entire functionality below that. Anyway, so to create the definition of this declaration, just click on the screwdriver icon, or rather the little arrow beside it, and then Visual Studio will offer a very handy feature to just create the definition of BeginPlay over here. Right, ta-da! We've got our BeginPlay function right in our C++ class. Now that we have our definition, we just need to add one more thing. Type in the keyword super colon BeginPlay brackets and semicolon. We use this super keyword to make sure that we are adding to the functionality of the base class function and not replacing it. Very handy keyword to avoid typing the base class every time we need to call one of its functions. This is because the test player controller is actually derived from the A player controller class. So we are just inheriting the BeginPlay function and we are actually adding to the functionality. We are not replacing the BeginPlay function entirely. Next, we need to set up the input. Notice that all the movement functionality already exists in your player character class. We do not need to recreate everything in our player controller class. Okay, so what we need to do is we need to create another function and add a setup input component function derived from the base A player controller class. So if you click control and click on A player controller, it should open the base class. And now if you press Control F and type in setup input component, you can see that we already have a setup input component function in here. Okay, and this allows us to set up custom input bindings the tab key that we have selected to switch the characters. So we just need to inherit that function as well. So how do we do that? Let's see. We do the same thing that we did for our begin play function. So go back to your header file, testplayercontroller.h. Make sure we type in the virtual void keywords. Type in setup input component. Make sure we get the spelling right and then type in override. There we go. Now create the definition for it by again selecting the screwdriver icon, create the definition. There we have it. This is our definition. Mandatory super keyword colon setup input component. Bang, done. Next we need to call the bind action function from the input component. So how do we do that? Type in input component. There we go. Bind action, and now we provide the parameters. The first parameter is the action binding. So what action binding did we create? If you go back to Unreal Engine, you can see in our project settings that we have created a switch character action mapping. So it's actually a string, so we need to pass in this exact same string. So you can select it, copy it, and then paste it between two inverted commas like so. Okay, next we select the enum. We need IE pressed, so when we press the key something happens. That's why IE underscore pressed, comma. Then we need a reference to the player controller. So this is the player controller, so that's why we need to give its reference. The keyword to use over there is this. Nice. And then we need to provide the memory address of the switch character function in this particular player controller. But we have not created that function yet, so we can just type in and a test player controller, right? This is the a test player controller. Select that one, double click, right? And over here we need to type in the name of the function that we are going to create. We haven't created that function yet, but we can just type it in right now. Switch characters. Now usually the function that we create is shown in the context menu over here, but we haven't created that, so it won't show it. Okay, go back, press the semicolon, and job done. Now the first thing to do is to create that particular function, switch characters. So you copy that, you go back to the controller, header file, void switch characters, created the function, waiting for it, there we go. Now we create the definition for it, create the definition, wonderful, and the red squiggly line is gone. There. Okay, so now we have the bare minimum number of functions needed for our class. However, there's one thing missing. Usually classes come with constructors, and they are usually created for us when we create new C++ classes in Unreal Engine. However, we do not have a constructor in our class, so let's go ahead and create that now. Go back to your testplayercontroller.h, type in a testplayercontroller, there you go, and then just put two brackets in front of it and then a semicolon. That, my dear friends, is your constructor for this class. right? Now we have created the constructor declaration, but we have not created the constructor definition. So how do we do that? We go back to our CPP file, make sure our cursor is right at the end of the include, and then we start typing the name of our class. That's a test player controller colon a test player controller, and parentheses. There, this is our constructor. Usually the constructors are placed at the top, and there's also a thing called as a destructor, which cleans up everything after the class has done its job, and the destructor is placed at the bottom. But for now, just put the constructor right below the include files. Now how do we create the switching functionality? Usually swapping algorithms are pretty straightforward, but we are going to create another version, albeit with the same core functionality that uses the T-array feature in Unreal Engine. So let's see how to do that. At this point, usually in other tutorials, what you see is that the code is written directly. However, we are going to do things a little bit differently. We are going to write down what we are going to do in plain English language. We create a sort of an algorithm kind of thing, and then we proceed according to that algorithm. Okay, so what algorithm are we going to create? Here we go. So what we need is, at the start of the game, we try to get the type of the controlled character. This is because we need to test our player controller class and see that if it is possessing some character or not. Okay, we then store it in a variable. So you remember that in one of the previous videos we changed the default pawn class in the game mode. That is what will be returned in that particular function, and this is what we will store in this variable. Then we initialize this variable in our constructor. Okay, if it is a null or garbage value, we display an error message. Otherwise we display a successful verbose message. This is just a bit of a defensive programming, and it helps you debug your programs a bit easily. And we do all of this in our begin play function. So let's do that. Right then, so how do we get the type of controlled character? We need a function to do that. So create a getter function of the type a pawn star. A pawn star get controlled character, logical naming of the functions. Now here we've got two choices. Since this is a getter function, we can either create a definition of this declaration in your testplayercontroller.cpp, or we can use something called as an inline declaration. It goes like this. We use our curly brackets. This function needs to return something, so we use the return keyword, and then we need to get the controlled pawn. But since it is going to be a character that is going to be controlled, we need to convert it into a pawn. So how do we do that? We use a cast a pawn, and then we use the function get pawn. Close the brackets, close the bracket, and make sure we have a semicolon at the end of it. There we go. This function will get the controlled character and then return it. Right, so the next step is we store it in the variable, right? That means we need to create a new variable. What's the variable type? Since we are creating a function that returns a pawn, we need to create a variable of that same type. So type in a pawn, make it a pointer, and then name that variable possessed character. So now we have a function and a variable that gets the controlled pawn of our test player controller. Now we need to initialize this variable in our constructor. So let's do that. Here's our constructor. Type in, there we go, type in possessed character, there we go, equal to null ptr. Okay, that's it. We have now created a variable, a function, and we have initialized the variable to a null pointer so that it is free to accept the returned variable from the function. Now we need to store the result of the function that we just created into this possessed character variable. So let's do that. Possessed character equals to get controlled pawn. Is it get controlled character? Yes, get controlled character. IntelliSense doing the hard work for us. Close the brackets and semicolon. Next, we need to check if it's a null or garbage value, and then we display an error message. Do that, we have an if condition. If our possessed character equals a null value for some reason, if the actor or the pawn that is being possessed by the test player controller suddenly gets destroyed, then this condition kicks in. So now we need to display an error message. Now we can do this in two ways. First way is to use UE_log macro, or we can also use another way that displays the error message right on the screen. The UE_log actually creates verbose error messages and then displays it in the output log in your Unreal Engine. So let's use the other one. The command for displaying the error on the actual viewport screen is gengine. Do we have gengine? Yes, we have gengine. And the command is add on screen debug message. Here we go. Add on screen debug message. We provide an index none. We do not need any kind of index over here. Index none. How many seconds? Right, time to display, how many seconds? Let's say 1 second. You can increase it to 2 seconds as well, it's not a problem. Oops, not 22, 2 seconds. Right, now we need the color for the display message, so we use fcolor enum, and then which one do we use? Black, blue, cyan, emerald. Since this is a debug message, let's use magenta. Okay, emerald. And then we display our text message. So what is our text message going to be? Pardon me, this has gone out of our window, so here we go. Right, just some generic error message should be fine. So test player controller not possessing anything. This is because it's a begin play, and at the start of the game, if the player controller is not possessing anything, then we need to display that error message. It's a really handy debug message for us. End that with a semicolon and job done. However, our task is not yet finished. We still need to display a successful verbose message if the possessed character actually has something in it. So type in an else, and we use the same format, G-engine. So now instead of typing everything, you just select all of that, Control C, Control V. Can we paste it in here? I think we can paste it in here, Control V. Now we just type in test player controller possessed a pawn successfully. There you go, 3 exclamation marks for good measure. And that's it. We have completed the first part of our algorithm. Now, for our switch function, our first job is to check whether our possessed character is valid as a part of our defensive programming. So we create an if condition. There we go. If possessed character is not equal to null, that means it's valid, then we proceed further. Right? Now we need to check if either the red or blue characters is already possessed. To do that, we are going to need another if condition and 2 boolean variables. Each variable helps to ascertain if either the red or blue character is possessed by our controller. So let's go ahead and do that. First we need 2 variables, boolean variables. So bool is red possessed. We initialize them to false. Similarly, bool is blue possessed. Initialize that to false as well. Now that we have our 2 boolean variables, let's create that if condition back in our CPP. So now here, it's up to you whether you want to check if the blue character is possessed first, or if you want to check the red character is possessed first. Doesn't make any difference, right? So if now here we type in is red possessed, or not is blue possessed. So basically we are trying to see if the red character is possessed or if the blue character is not possessed. If either of those conditions are true, then we proceed further. This is necessary because when you start the game, neither the red character nor the blue character is possessed. So we need to check either or. Okay? Our controller is actually possessing the default pawn when we start the game. And that's why we need this or condition. Alright? Alright. So let's go ahead. Now we need our custom player controller to unpossess whatever it is controlling, whether it is the default pawn that we assign in the game mode, or the red character or the blue character. So to do that, we use the unpossess function. So that means it's referring to the custom player controller that we have created, and we call the unpossess function like so. So far so good. Now we create our temporary variable for the simple swapping function, just like the other tutorials. Here we go. A pawn star new possessed character, or temp possessed character. You can have any name for the variable you like, and then we initialize this to null pointer. It's important to know that we are creating local variables specifically for the switch characters function. Now at this step, we start doing things in a different manner. We create our T array first to store the character that we are supposed to find from the level. So go ahead and make that T array like so, of the type A actor pointer, and name that array to something logical. I just named it actors with tag. Okay, now we can use a special function from the gameplay statics library called get all actors with tag and store that in our T array. I'm going to show you how that works. Okay, so you type in uGameplay statics, right? Now this throws a red squiggly line or the error because we haven't included the uGameplay statics library in our header file. So we go back to the header file, make sure our cursor is at the end of the player controller.h, press enter, make sure any included files are before the generated.h files to make it work, hash include. Now this particular gameplay statics is in the Kismet folder, so Kismet, right, and gameplay statics. Let's see, there we go, gameplay statics .h, all done. Save, go back to the CPP, and now you see we have access to the uGameplay statics library. Okay, now what function are we going to call? Get all actors with tag. Let's see, should be a namespace. Get all actors with tag, there we go. Get all actors with tag, and what is it requiring? It requires the world context object, so we just type in get world, so it will get the current world that we are in the game. Now here you specify whether you want to do the red character first or the blue character first. Since in our if condition we are checking if the blue character is not possessed, we are going to find out all the actors or the characters that have the tag blue. So type in BLUE, make sure the spelling matches the tag that we put in the Unreal Engine previously. And then we use the T array. You see over here it requires a T array to populate the return characters. That's why we type in the name of our T array that we created previously. So actors with tag, there we go, the context menu just types it in for us, actors with tag, and we put a semicolon afterwards. Fantastic. Now we need to verify that our array is not empty for whatever reason using an if condition. So the way to do that is, let's type in an if statement, actors with tag, that's the name of our T array, and we call the function num, right, and then we check if it's not equal to 0. That means we check if the T array is not empty. At this point we can either use a for loop to get the only element in the array, or there's a much better way. We just call the top function of the T array data type, and then we just get the topmost element, which is really the only element in the array, and then store it in a temporary variable. So let's do that. Okay, so I'm going to use the new method, new possessed character equal to, we need a cast over here because the return value needs to be converted. A pawn or cast, a actor, and here, oops, a actor, and then inside the brackets we find our a actors with tag, that's the T array, and then we call the top function from there. Put a semicolon in there, and then we've got our job done. For anyone who is not familiar with this or can't get this to work, it's basically the same thing as typing a for loop. So here's the for loop for that. So we do the for int I equals 0, I plus plus, sorry, not I plus plus, I less than actor with tag dot num, right, and then I plus plus, that's the for loop. And then inside the for loop we just use new possessed character equals cast a pawn, a actor, and then actors with tag, if I can type properly, actors with tag, and then the element I. A actor, let's correct those spellings, a pawn. So this is the same thing. This whole piece of code does the exact same thing as this. The reason I've chosen this is that it's a direct way of doing things. It's less lines of code and it's straightforward. So you can just delete that, or I'm just going to comment it out so that anyone who needs to check if the for loop works, you can just type in that code and then check it out. Okay. Once all of this is done, we can then use the possess function from our custom player controller class to take over the blue or the red character depending on our if condition. For us, it's the blue character, so we are going to possess the blue character. Possess and new possess character, the temporary variable that we just used. Don't forget the semicolon. Now after this, we need to flip the boolean for the blue character. So is blue possessed equals to true. And that means we acknowledge the fact that the blue character is now successfully possessed by the player controller class. Now you can ignore the status of the is red character because we have already set it to false. But for peace of mind and for systematic behavior, we also make sure that the boolean for the red character is set to false properly. Okay, now after that we need to use the empty function of our TArray to clear out its contents. So we type in actors with tag dot empty, and that's it. Now many people will argue or say that there's no need to do this because the TArray is a local array which is within the scope of the switch character function. So as soon as the function goes out of scope, the TArray would be destroyed anyway. It's a valid point, So you could ignore that line and check for yourself if the array is emptied or if the actual array variable is destroyed after the switch characters function has done its job. Lastly, we use an else statement to add an error message if our function did not find any character to possess. And we use the same code as we have used before to add the on-screen debug messages. Okay, else g engine, there you go, g engine, add on-screen debug message. We are not using any key, so index underscore none. Alright, there we go. How many seconds do we want it to be displayed for? 2 seconds, so 2.0f. I'm going to use magenta as the color again for error messages. Magenta. Text. What text do we need to display? We need to display no characters found. And then we are making sure that these messages or the new messages will be displayed on top by giving in a boolean true value, as you can see in the definition of that function. And lastly, what scale do we want our message to be? So f vector 1.5f comma 1.5f. That should do the trick. And bracket f vector 2d. There we go. Now that we have created this functionality for the blue character, we can use the same code to create the exact same functionality for the red character. We just need to change the if condition at the start of the functionality. We change the tag from blue to red, and then we flip the boolean variables. So now let's go ahead and do that. The only difference will be, instead of the if condition, we are going to be using else if. Here we go. So it's the same thing. Now we just change this to else if. Now instead of is red possessed, we are going to say not is red possessed, and we remove the exclamation mark from the is blue possessed. We change the tag from blue to red, and we flip the boolean variables. So is blue possessed false, and is red possessed to true. That's it. Excellent. Now we have the functionality to check for blue character. So possess the blue character, switch to blue character, as well as the functionality to check for the red character. There we go. So everything should be in place. Now all that remains to be done is save the file. So Ctrl+Shift+S, everything is saved, and then we go back to Unreal Engine and we click on live coding and hope that everything works fine. Let's see. Hopefully there should be no errors. Live coding successful, fantastic, and that's it. We have created the code for our switching functionality entirely in C++. Now we will test it for errors and bugs in the next video. See you then. Now, before we go in and test our functionality, you might notice that in our test player controller CPP file and our header file, I have not included the inherited tick function here. That's because we do not need any specific functionality to happen every frame for our project in this class. So we can safely ignore creating a separate inherited tick function, knowing that the original function in the base class will do its thing. This is one of the ways you can keep your code simple and uncluttered.